there. Welcome to Astraveo's Continuing Education series, where for our podcast listeners we talk about mathematics, the physical sciences, of course the natural world, and our personal favourites, astronomy. Now, you know Joseph and I are all up in and about astronomy. We get super excited about that stuff. So let's get going. For today's episode of Astraveo's Continuing Education series, we're going to be focusing on the Pythagorean Theorem, which describes the relationships between the lengths of the three sides of a right-angled or 90-degree triangle. As the name suggests, the theorem was developed by Pythagoras, who was a great ancient Greek philosopher who developed the theory about 2,500 years ago on the island of Samos in Greece. Let's get started. So what we can do is we can describe a right-angled triangle as a triangle having a 90-degree angle. And as you can see, it's depicted here by a 90-degree symbol. Here's the degrees and here's the square. This little square says that it's a 90-degree or right-angled triangle. And what Pythagoras said is that we can relate the lengths of the sides of this triangle to each other. And he said, let this side be A, let this side be B, and let this very long side C, which we call the hypotenuse, the longest side of a right-angled triangle. The relationship between these sides can be written like this: A squared plus B squared equals C squared. Now in words we can think of it like this. The sum is the plus symbol. The sum of the squares, here's the squares, of two sides of a right-angled triangle equals the square, here's the square here, of the remaining side. So what that really means is this length squared plus this length squared must equal this length squared. And we can demonstrate that quite nicely. We can take another right-angled triangle. Here's the 90-degree triangle right here, remember, there's the little square, so it's a 90-degree triangle. Let's assume this is 3 centimetres in length, this side, A. Okay, we're going to call it A. Let's assume this side is 4 centimetres, and we're going to call that B. We would like to know what the length of C is. So according to the Pythagorean theorem, it's quite simple. We know that A squared plus B squared equals C squared. We know that's true. That's our fundamental statement of the Pythagorean theorem. Well, we know what A is. A is 3 centimetres. We know what B is. It is 4 centimetres. And that remains to be seen yet what C is. We have to work out C. Now let's move up here so we have some more space. 3 squared is 9. 4 squared is just 4 times 4, that's what squared means, times itself. So 4 squared is 16, and that is going to equal C squared. Well, 9 plus 16 equals 25. So 25 equals C squared. Now, we want C, not C squared. It's just C times itself. Now, the best way to get rid of a square operation in mathematics is to take the square root. And we depict it by this funny looking symbol here, with a little 2. A funny little symbol again on both sides. Remember, if you have an equal sign, what you do to one side of the equation, you have to do to the other side of the equation. Now, the square root of 25, we know, is plus or minus 5. Plus or minus 5. The square root of anything squared is just itself. So the square root of C squared is just C. Now that's our answer. C, we can't have a negative distance, so we have to take the positive. So C is 5. Don't forget the units, very, very important. Centimetres. So we know that this triangle, the hypotenuse, has to be 5 centimetres. Now we may be asking ourselves, why is there a plus and minus? Well, don't forget, any number times itself gives you the square. So if we take plus 5 times plus 5, that gives us the 25. But if we take minus 5 times minus 5, 2 minuses multiplied make a plus, don't forget, Minus 5 times minus 5 also gives us 25. So we have to have this operand plus or minus. But of course in the real world you don't get negative distances, so you can ignore the minus sign. And that really is all the Pythagorean theorem is. It's just working out the lengths of the sides of a right-angled or 90-degree triangle. Now don't forget, there are many practical examples of how to use this in the real world. It can be used in architecture, in agriculture, in education, of course, in science, but also in something like sports. So let's do an illustrative example that you might expect to see perhaps on a 7th or 8th grade mathematics test. So perhaps if your child or your student is 10, 11, 12, something of that order, you might expect to be starting to see the Pythagorean theorem crop up. So let's do a real world example. Okay, let's give ourselves some space. So I'm going to erase the workings out so far. Okay. Now what we're going to do, because I live in the United States, we're going to pick on a sport, and I actually love football, soccer, but we're going to pick on American football because this is a really easy example to do. In American football, in the middle of the field, you have a quarterback who typically throws the ball and directs play. Now my favourite team is the Dallas Cowboys, best team ever, of course. Now at the moment we have a really fabulous quarterback called Dak Prescott. Here's Dak, here he is in the middle. Now he has a very special wide receiver, the person that catches the ball, typically out here on the wing, and I'm going to put a little star there for him. Now he's called CD Lamb, super duper player, really, really good. Okay, we're going to call him CD Lamb. Now this distance can be anything. CD Lamb can be quite close to the quarterback, but typically he's out on the sidelines so that he can run up the wing, catch the ball and make a lot of distance and hopefully score a touchdown. Well, we have to figure out how far Dak is going to throw the ball to CD. So let's assume that CD Lamb is 15 yards away from the centre of the field. Now he's going to run a route, a special pattern of, let's say, 20 yards. Okay, I'm going to make this line a little bit bigger just to be nice and scaled correctly. 20 yards. Now perhaps Dak is thinking to himself, CD is going to run 20 yards, I have to throw the ball 20 yards. But of course that isn't true. Dak actually has to throw the ball along the hypotenuse, because look, guess what? This is a right-angled triangle. So in fact, this line here, the trajectory of the ball he has to throw for CD to catch it after 20 yards, has to be much longer than either the 15 yards or the 20 yards, because it's the longest side of our right-angled triangle. It's the hypotenuse. So, how far does Dak does he have to throw the ball? Now, he's a super-duper quarterback. He's been doing this for years. He's very experienced, has a lot of skill. But his coaches have trained him over the years to know he has to throw the ball farther so that his wide receivers can catch the ball. Now, the coaches, I bet, have done some Pythagorean theorem in the background to work the number out to tell Dak how far to throw. And here's how Dak can figure this out. So don't forget, the Pythagorean theorem can be written as a squared plus b squared equals, in this case, question mark squared. Sorry, my pen's squeaking a little bit. So let's call the distance from CD Lamb to the quarterback when they're starting A. Let's call the distance that CD Lamb is going to run up the sidelines B, the 20 yards. Well, the only thing we have to work out now is how far Dak has to throw the ball along the hypotenuse here. So it's not too bad. A is 15, so we do 15 squared plus B squared. Now B is 20, so we're going to do 20 squared. And that is going to equal the square of the distance that Dak has to throw the ball in order for CD Lamb to catch the ball. Now 15 squared is one of those beautiful numbers. It's obviously a magic number, it's a square. So 3 squared is 9, 4 squared is 16, 10 squared is 100, for instance. Now, me being a scientist, I actually really like the square numbers. I happen to know that 15 squared is 225. 225. Now 20 squared, I don't think you have to be a really strong mathematician or even a scientist to work this out. It really is just 2 squared, which is 4, add 2 zeros, because it's 20 times itself. So we give it the 4 and the 2 zeros, 20 squared is 400. Don't forget our equal sign. That's the square of the distance that Dak has to throw the ball. So if you add these two up, you get 400, 600, and 25. So we have 625 equals the square of how far Dak has to throw the ball to CD Lam. To get rid of the square symbol, we have to take the square root. And I'm going to put a little symbol here because you can get multiple roots actually. So the square root of something squared is just itself, we know that. Now the square root of this number I happen to know off the top of my head, but I will show you how to calculate it. It's not very difficult. Okay. 6, 2, 5. Little 2 there to show it's a square root. Now 625 is also 5 times 125. Well, that number is also 5 times 125 also happens to be 5 times 25. So what that can equal to is 5 times 5 is 25 times 25. A square is just any number times itself. So the square root of any number times itself is just itself. So the square root of 25 times 25 is indeed just 25, plus or minus, of course. So this number here is plus or minus 25, and don't forget our units here, it's yards. Now again, we cannot have a negative distance in the real world. So this distance here that Zach has to throw the ball so that CD Lam catches it and is able to make yards, make a first down or hopefully a touchdown, is 25 yards. So not only is it through experience that Dak Prescott and all good quarterbacks know how far to throw the ball when their wide receivers are running up certain patterns, it is also the case that probably some of their really good offensive coaches have worked out the distance previously, and they've done it using the Pythagorean theorem. So it's a very, very useful theorem for all kinds of things in the real world, including sports, education, science, agriculture, even art, of course. You need to have some very precise units sometimes when you're doing your artwork. So it has a great many practical examples in the real world. Thank you for joining us.